Friends, welcome to Beneath Mac Academy. First of all, I apologize for the making the today video in a late manner because of certain technical updation. We couldn't publish by the evening. So by now, after 10 o'clock, all the videos in English with this topic will be published today by for day 2. Okay, friends, let's move to the video. Okay, in the number system, book 6th standard, volume term 2, volume 2, we are going to it. Okay, let's see. The first topic we are going to see is what is odd number, what is even number. The number which ends which are 1, 3, 5, 7 and so on, 73, 75, 2009, whatever it is, it called as odd number. The number 2, 4, 6, 8, 10 and so on up to the any 4592, any number is called as even number. In simple manner, any digits ends with 1, 3, 5, 7, 9 is called as odd numbers. 2, 0, 2, 4, 6, 8, if any numbers end, that is called as even numbers. In whole numbers, odd and even number come alternatively. Okay. Thinking about factors. Factors is a number which that divides the given number exactly and gives zero remainder. Every number at least has two factors, that one and itself. Okay. Every factor number is less than or equal to that number. Okay. Here they given some examples of factors. Okay. What is you going to learn in this chapter is you are going to learn what is prime and composite number and divisibility, then HCF LCM. Okay. What is a prime number? If number which is divided by 1 and itself is called as prime number. For example, 13. The number which is divided by only by 1 and by 13 itself, so it is called as prime number. The next one is composite number. Composite number. If a number has more than two factors, if a number is divided more than 1 and by itself, it is called as composite number. Let us see an example. 15. Number 15, which is divided by 1, 3 and 5 and 15. So it is a composite number. Okay. Then we should understand a concept called as perfect number. A perfect number is if the sum of factors other than the given number gives the same number is called as perfect number. Let us see an example. If the factors of 6 is 1, 2, 3, except the number you should not count 6. Okay. So 1, 2, 3. If it add it on, it gives the same number. It is 6. Okay. Same as there is other perfect number like 28, 58, 54 and 496. These are the perfect numbers. Okay. Sometimes they may ask you in the TNPSC examination by giving this any of the four numbers, like which is a perfect number. Then you should understand the concept what is a perfect number. Given some examples, you don't need to see all those basic questions. Okay. Then there is a concept called as twin prime number. A pair of number whose difference is equal to is called as twin primes. Okay. For example, in case of prime number, the difference between the two prime number should be 2. Then that is called as twin prime pair. Okay. Let's give an example like 5, 7. The difference between 5 and 7 is 2. Both are prime numbers. So that is called as twin primes. Same as there is another pair called as 17, 19. The difference between the two numbers is 2. So it is also called as twin prime numbers. If there is a 3 successive prime numbers differ by 2, then that is called as prime triplet. Okay. If there is a 3 different number, all the difference between the 3 number is 2, then that is called as prime triplet. The example for that is 3, 5, 7. The difference between every two number is 2. So it is called as prime triplet. Okay. Okay. Then divisibility. See, normally most of the academies they prefer to give a separate video for divisibility. How the number is divided, what are the shortcuts to find the number is divisible by 2, 3, 4, 6. So, but in case of 6th standard itself, books the exercise and books itself. Divisibilities are given with a proper and clear cut examples. So let's see. If a number is divided by 2, it has to end with 0, 2, 4, 6 and 8. Okay, let's see an example. 4,56,368. You never need to know anything apart from the last digit of the number. What is the last digit? 8. 8 is divided by 2. So the number is always divisible by 2. Okay, let's see another example. 12,34,567. The last digit of the number is 7, which is not an even number. So which is not divided by 2. Okay, then divisibility by 3. என்ன பார்க்கணும் அப்படினா ஒரு நம்பர் வந்து if it is divisible by 3 அப்படினா the total of the number should be also divisible by 3. Example இங்க 96 ன்னு ஒரு நம்பர் கொடுத்திருக்காங்க. So 9 plus 5 6 is 15. So directly it is divisible by 3. So once again we will add it. 1 plus 5 is 6. So 6 is divisible by 3. So the value is also divisible by 3. Okay, here they given another example. 6,54,321. If I add it, we will get 21. So once again 2 plus 1 is 3. So 3 is divisible by 3. So 6,54,321 is also divisible by 3. Divisibility by 5. Very simple. If a number ends with 5 or 0, keep it in mind, if a number ends with 5 or 0, it is divisible by 5. Okay, they give an example. 5,225, it ends with 5, so it is divisible by 5. 280, it is ends with 0, so it is also divisible by 5. Okay, then divisibility by 4. It is very simple. You just take last 2 digit. Let's see the example. 492. 492, you take the last 2 digit as ones and tens, that is 92. Okay, if a number is divided by the last 2 digit by 4, if 92 is divided by 4, yes, it is divided by 4, then the whole number is also divisible by 4. Same as if the last 2 digits of a number is 0, 00, is also divisible by 4. Okay, let's see the example. 2,900, the last 2 digits are 0, so it is also divisible by 4. Then divisibility by 6. If a number is divisible by both 2 and 3, it is also divisible by 6. Okay, what is the rule for 2? The number should end with 0, 2, 4, 6, 8, 0, 8. What is the rules for regulation for divisible by 3? The total value should be divisible by 3. Okay, so let's take an example. 138. The last digit is 8, so it is divisible by 2. 1 plus 3, 4, 4 plus 8, 12. 1 plus 2 is 3, so 3 is divisible by 3. So 130 is divisible by both 2 and 3, so the number is also divisible by 6. Okay, they are here in the books, they are not given the divisibility rule for 7, but there is a trick we will be seeing in the later part of the video. Divisibility by 8. If a number is divisible by 8, the last 3 digits of the number is divisible by 8. See what we seen in the 4, last 2 digit. In case of 8, we have to see the last 3 digits, ones, tens, hundreds. Okay, so here let us see 2,999. Then 999 is divisible by 8, so the total number is also divisible by 8. There is another factor also. If the last 3 digits are 0, see in 4 we see last 2 digits are 0, it means it is divisible by 8. Same as in case of 8, last 3 digit is 0, the number is divisible by 8. Okay, divisibility by 9. If a number is divisible 9, if the sum of total divisible is 9, by example 9,567, if you add it, 9 plus 5 plus 6 plus 7, it's 27. So 27 is divisible by 9, so the number is also divisible by 9. There is a hint that or note that if a number is divisible by 9, same as the number is also divisible by 3. Okay, then divisible by 10. If a number ends with 0 in the 1th place, say, okay, that is example. Let's see 2020, the last digit is 0, one's digit is 0, so the number will be divisible by 10. Okay, then divisibility by 11. If total of sum of digits for alternative number is either 0 or divisible by 11. Okay, let's see the example, you will feel finding it out. to 2,56,795. So you have to consider all the odd slot in that number. Okay, 2 plus 6 plus 9 minus 5 plus 7 plus 5, that is 1th digit, 3rd digit, 5th digit, 2nd digit, 4th digit, 6th digit. Okay, if first 1 digit, 3rd digit, 5th digit, total is 17, 2nd digit, 4th digit, 16 digit, the difference is also 17. The difference is 0. If the difference either should be in 0 or number is should be in the multiple or divisible number of 11, like 22, 44, 77. Okay, these are the divisibility numbers. Okay, then prime factorization. There are two methods in this. One is division method, another is factory tree method. We normally follow division method. Okay, division method is not that method that we follow in our study. Okay, here they specify division method another way. Normally used to practice like this: 36, 2, 18, 2, 9, 3, 3, once again 3, 1. So இப்படி நம்ம நார்மலா பண்ணுவோம் இல்லையா? So இதுதான் என்னது prime factorization method or division methodல நம்ம கண்டறது prime factorization கண்டுபிடிக்க. So what is the factors? 2 into 2 into 3 into 3. These are the factors of 36. That is they specified it. Okay. So you no need to follow the factory tree method. It is quite complicated compared to division method. So let us follow division method is alone sufficient for our calculation. So let's move to the exercise number 1.1. Okay, I tell you one thing. The reason behind the technical issue or delay of publishing today video is now we are going to see. Okay. Okay. Most of the viewers have said that calculating on the window screen of a window is it's not so clear. So let us write the answers so then we can discuss for the video அப்படின்னு சொல்லி சஜஷன்ஸ் கொடுத்துருந்தாங்க. ஸோ அந்த சஜஷன்ஸை நம்ம இம்ப்ளிமெண்ட் பண்ணுறதுக்காக we take lot of efforts. ஸோ அந்த டெக்னிக்கல் ரீசன்னால தான் இன்றைக்கி வீடியோஸ் கொஞ்சம் டிலே ஆகிருக்கு. சரியா ஃப்ரெண்ட்ஸ்? ஸோ from today onwards it will not be get delayed. Okay, so number of prime numbers between 11 and 16. So I already told you that in a previous video itself, and I'm also remembering it now. Once you should remember what are the prime numbers between 1 and 100. As a TNPA aspirant, you should remember that. So I'm not going to answer this question. So you yourself answer this question. Okay. The number 28 and dash are the twin primes. What is twin primes? If a gap between a two prime number is 2, then it is called as twin primes. If one number is 29, there are the chances of other two numbers either 27 or 31. 27 is not a prime number. Then you'll have to look at 31. 37 is a prime number. So answer is 31. The difference between the two numbers is 31. Okay. 29 and 31. The difference is 2. See the next question. 3759 is divisible 9. Hence the divisible by 3 plus 5 plus 7 plus 3 is 18. So 1 plus 8 is 9. So it's divisible by 9. When you study the concept of divisible by 9, they mentioned a note. Okay, they says that if a number is divisible by 9, it is also divisible by 3. They are asking testing the concept. The number of distant prime factor among of the smallest 4-digit number is two. Okay, then let me check the fifth question. The sum of distinct prime number of factor 30 is, they are asking about sum of, say what are the factors if you divide it in this method, 30, 2, 15, 3, then 5, 1 5 are 5, so 2 into 3 into 5. So if they asked about sum of, that is total of 2 plus 3 plus 5 is 10, that is the answer. We just ignore true and false. Let's move to the question number 3. Write the smallest and biggest 2-digit prime number. See, first of all we should know what is the smallest and biggest 2-digit number. Smallest 2-digit number is 10 and biggest 2-digit number is 99. So 10 is not a prime number. So next number is 11. So 11 is a prime number. Same in case of 99 is not a prime number. So 98 it's also not a prime number. but 97 is a prime number. So smallest prime number is 11 and largest 2-digit prime number is 97. Okay, the next question is, what write the smallest and biggest 3-digit composite numbers? The composite number is, what is a composite number? If a number is divisible by more than 2 factors, it's called as composite numbers. Okay, the smallest 3-digit number is 100 and largest 3-digit number is 999. Okay, so 100 is a composite number because it has more than 2 factor variables, that is it can be divided by 1, 10, 5, 10 and so on, 20, so on. Okay, same as in case of 999, it can be divided by 1, 3, 9 and so on. So both are composite numbers. So 199 is the answers. So let's check the next question. Your friend says that every odd number is a prime. Give an example to prove him that he is wrong. Okay, before that there is a question. Sixth question. The digits of the prime number is 13 and we reverse that to get a prime number is 31. Find if such pairs in the existing up to 100. ஒரு நம்பர் இப்போ எக்ஸாம்பிள் பார்த்தீங்கன்னா 13 அப்படின்ற அந்த நம்பர் வந்து ரிவர்ஸ் எழுதினோம்னா என்ன ஆகும், 31 ஆகும். இட் இஸ் ஆல்சோ ஏ பிரைம் நம்பர். ஸோ இந்த மாதிரி பேர்ஸ் வந்து ஒரு நம்பர் அதோட ரிவர்ஸும் அனதர் பிரைம் நம்பராக இருக்கிற மாதிரி இருக்க பேர்ஸ் வந்து என்னென்ன இருக்குது அப்படின்னு சொல்லி கேட்குறாங்க. அப் டு 100க்குள்ளே தெர் ஆர் 3 such pairs. என்னென்ன அப்படின்னு பார்த்தீங்க அப்படின்னா 17, 71, 37, 73, 79, 97. ஆக்சுவலி வந்து 4 ஆல்ரெடி அவங்க 1 கொடுத்துட்டாங்க. ஸோ அடிஷ்னலி இட் இஸ் மோர் 3. Okay. Your friend says every odd number is a prime number. Every odd number is prime number னு சொல்லிருக்காங்க. Okay, give me an example to him some. So 9 is a odd number, okay, but it is not a prime number, so it is hence it's proved. Okay, each composite have at least 3 factors. Justify this statement with the example. Okay. 6 is a composite number because it has more than 3 factors, right? 1, 2, 3, 6. These are the composite factors of 6. Find the dates of a calendar which are divisible by 2 and 3. Very simple. So let me write the days in a month. It starts from 1 and goes up to 31. In some months it is 30. In February it is 28. In case of normal year, in case of leap year it is 29. So I write all the dates. Okay. Let me I have rounded in the red color pen all the numbers which are divisible by 2. I have rounded the numbers which are divisible by 3 in a violet color ink pen. Okay, you see it, you can find it on. In the certain numbers it is rounded by both colors. You see 6, 12, 18, 24, 30. These are the numbers which is rounded by both colors. That means these are the numbers which are divided both by 2 and 3. Okay, do you understand it? Okay, let me check the next question. I am a 2-digit prime number. The sum of my digit is 10. I am also a factor of 57. Who am I? Okay, you should know. I told you, no, you should know about all the prime numbers at least before 100, 1 to 100. Okay, they asked you to tell that it is a 2-digit prime number. The sum of my digit is 10. Okay, so let me check with what are 2-digit prime number. The first 2-digit prime number is 11. So if you sum it, you will get only 2. Okay, then next 13. If you sum it, you will get only what? 4. Okay, then what is the next prime number? Is 17. 17 you will sum it out, you will get only 8. The next prime number is 19. If you sum it, you will get 10. Okay, first criteria is matched. I am also the factors of 67. Yes, 19 is a factor of 57. 3 19s are 57. Okay, so the answer is 19. Okay, the next question is, find the factorization of each number by factory tree method. We ignore it because we don't follow factory tree method, we use division method. So if we follow it, we will answer it easily, the answers will come. Okay, if there are 143 math books to be arranged equal number in stacks, the number of books in each stack and the number also the number of stacks. ஸோ இந்த மாதிரி கொடுத்தாங்கன்னா கொஸ்டின் இஸ் வெரி சிம்பிள். நம்ம என்ன பண்ணோம்னா இதை அப்படியே டிவிஷன் மெத்தடில் போடணும். போட்டு HCF கண்டுபிடிச்சோம் அப்படின்னா த ஆன்சர் இஸ் வெரி சிம்பிள். ஓகே, 143 11 டைம்ஸ். ஸோ அடுத்து 13 திருப்பி LCF போட்டிங்கன்னா 13 தான். So 11 and 13 either 11 books 13 racks la edukkalam illa 13 racks la 11 books edikalam. So in the either way we can follow it. Okay, the next question is difference between two successive odd numbers. See here, 2 and 4 are the odd numbers. Let us assume the difference between them is 2. Answer is 2. The only even prime number, you never even forget in your sleep, okay, because the only even prime number is 2. Which of the following is not a prime? You can very well tell that by seeing itself. The number ends with 2 is always it is divisible by 2. So 92 is the answer. The sum of factor of 27 is, see here, which of the following is not a prime? Sum of factor of 27 is, okay, the factor of 27 here, see here, 1, 3, 9, 27. If you add it, you will get 40. So answer is 40. C. The factors of prime number 1, 2, 4, 5, 8, 10, 16, 20, 40 and 80. So you see the answers. If it is 100, you know, there is a number called as 16. It cannot be a factor of 100. So we can ignore it. 128 is also not a factor of 16. So we can ignore it. But you have two values, 80 and 60. If there is a 160, it should be also a factor of that number, you know. So we can ignore it. So you can directly tell that 80 is the answer. Okay, 8 is the answer. The next one is the prime factorization of 60 is 2 into 2 into 3 into 5. Any other number which has same factorization as 60. It is never possible. It is not at all possible, because if we multiply all the factorial, we will get 60. So it is not possible. So it is impossible to get the same factor values. Okay. If the number is 6354 star 97, in the star, if the number is divisible by 9, what is the value of star? Okay, a very simple answer. So if you add it, 6 plus 3 plus 5 plus 4 plus star plus 9 is equal, you will get 34. So 34 is not divisible by 9. If you add a certain number which is divisible by 9, what you have to add? The nearest value, you see. If you add 2, it will get 36. So it is divisible by 9. You check with the answer, 2 is there. So if you add 2, it will get divisible by 9. Okay. The next number is 87,846 is divisible by, you check here, the number ends with 6. Okay, it is divisible by 2. Total of that number is 30. So 3 plus 0 is 3. So it is also divisible by 3. Okay. See the odd values. 135. 8 plus 6 is 22. Even values, second digit and fourth digit is 7 plus 4 is 11. So 22 minus 11 is 11. So 11 is 11 divisible by 11. So the number is divisible by 2, 3 and 11. So all of this. See the answer? We have all of this. Okay. So here you complete exercise 1.1. I hope, friends, comparing to the all previous videos, this gives you clear idea how to calculate and how we have maintained an effective presentation. Because of that, we had made a time delay for the uploading this video. So thanks for your patience and waiting for the video. See you in the next video, friends. Thank you.